We're going to start our Prayojana series to support COVID in its deep, in-depth, cross-disciplinary approach of putting a lot of information together by Joyce Grossman and Cheryl Ortel and Adesuwa Okesanya. All of them are medical physicians and also have other expertise. Cheryl, do you mind just going to the next one? Joyce Grossman is has 3 board certification, which is infectious disease, pediatrics, and internal medicine. She also has additional master's degree in cell biology, immunology from the Rockefeller University, and has a degree in microbiology and chemistry from Indiana University, and master's of science in genetics from Weill Cornell. With that kind of knowledge and background, with the understanding of large-scale population health, she's one of the best person to kind of help us understand what's going on with COVID and what can help. Cheryl Ortel is a medical doctor and semi-retired OBGYN. I call it semi-retired because she's never fully retired. And she's also a seasoned lecturer and has a master's in genetics. She has spent a great deal of time putting together a lot of evidence-based cross-disciplinary knowledge in COVID. And she's going to be, most of the things that you're going to see are put together, organized by Cheryl. Then Adesuwa Okesanya is a medical doctor. She will be moderating. Her background is in family medicine, virtual care, and she has been in the front line treating COVID patients inside hospitals and nursing homes. Cheryl, go ahead.
All right, so today, welcome everyone. This is the beginning of a 14-part series. And I'm going to talk to you today a little bit about the number of cases, some of the genetic modifiers of the disease, and maybe get into some mutations and what it all means for us as clinicians. So I'll talk a little bit about herd immunity, what it is, and how close we are to obtaining it. There's a lot of talk in the news right now about strain mutations, about the G clade, so I'm going to try to explain that for you in a more scientific basis. We're going to talk a little bit about ABO blood types and what they mean with COVID, how other cells are getting infected, and we'll talk a little bit about the ACE2 receptor binding site and things that are related to that, including how you get into the cells and some short discussion about X inactivation. So coronavirus is very common. It's the most common cause of colds. There's 200 different coronaviruses. They cause 7 different infections, 4 of which are respiratory. And we first heard of MERS, Middle East Respiratory Syndrome, in 2003. Then we heard of SARS Classic, which came next. SARS was an alpha coronavirus. And now we're going to be talking about SARS-CoV-2, which is a beta coronavirus. That the backbone comes from horseshoe bats in China. All viruses have a genome, so we would be remiss not to talk about that. So every virus you're going to hear about is going to have structural proteins. There are going to be envelope proteins, nucleocapsid proteins, and the S proteins, the spike protein for SARS-CoV-2, which is how that virus binds to human receptors. SARS is a rather large virus. It has about 30,000 base nucleotides, and it encodes for 29 proteins. And so the picture just will show you the typical model you probably all have seen. And the most important thing is how one gets into the cell from this virus. Now, we've all heard about flattening the curves. So this is what a typical modeled epidemic that has an exponential increase looks like. It has a very sharp peak and comes down. And so when we were told we needed to flatten the curve, what we wanted to do was reduce the number of initial infections so we would not overwhelm the healthcare system. And that was lockdown, social distancing, wearing a mask. And what that tends to do is to shorten the number of cases on at any particular time, but it ends up lengthening the time of the pandemic. So these are stylized graphs that come from modeling, not the real thing. And I hope that the pictures aren't putting this out, but what I wanted to show you was that in the United States, we did a really nice job of flattening the curve, and then very recently, because of 19 states, the curve is going up. Right? What I did was I took a ruler and I said so it's about an 8-week thing that happens. So I said, well, here's where we are on that idealized curve. How much do we look like this one? And then I put the arrow over here. You can see our curve was coming down at that particular time, and now it's going to be coming up again. So I wanted to show everyone what kind of difference it makes on what you do. And this was a very nice chart that was put out by Chris Martenson from Peak Prosperity. And you can see that South Korea, New Zealand, Australia, Taiwan, Hong Kong, Iceland, Estonia, Norway, Vietnam are here. They acted very quickly. They did not have proper PEE, personal protective equipment. They said, please, everybody in the country, we need your help make masks. They did that. They did social distancing, and theirs is a very nice low peak. A fast and weak will look like this, sort of get a second little peak. And there's the strong and slow. That peak will tend to look like this. And then there's the slow and the weak, with Belgium, United Kingdom, United States, Italy, France, and Spain having something that looked like this. But now the United States is breaking out on its own. So here's what we would look like if we did nothing. And here's that curve if we put into a lot of, we do the social distancing, masks, taking care of our behavior. And as you can see, in real life, we don't have a perfect curve, but we have something that looks very much, you can kind of make it out. So again, the United States, we flatten the curve, but we're starting to go up. And China, according to their data, and this is some new way of measuring they had here, they had a very small curve, and then they've stayed pretty flat, according to the data that they have put out. And just another look at us, I went to July 4th, and you can see we're starting to go up after the large gatherings with no face masks. And there's been spikes in about 19 states, so that makes this go up. Herd immunity will look like the completion of one of these curves. So here we have new cases, and very interesting, this is New Jersey. Looks very much like this curve, right? You can see it tick long, but it's kind of staying still. So they may have herd immunity. And then this was New York. Again, nice curve starts and it's petered out and now it's staying stable. So everybody's, you go, well, my goodness, they told us to get herd immunity, we needed to have 70% of the population infected. We know from the stats that are coming out that only 20 to 25% of New York City people have been infected. So what's the deal with herd immunity? So that is something I'm going to get to a little bit later. We're going to dig a little bit deeper, because herd immunity and that 70% apparently comes from having if you have a vaccine and you can vaccinate 70% of the population, you're going to get herd immunity. But yet we've got this beautiful curve like this, looking like there's herd immunity in New York and New Jersey. So does it make a difference? Should we wear a mask or shouldn't we wear a mask? And in the very beginning, there was a lot of conflicting information on the media reports. So that's when I started doing a lot more reading on COVID and all kinds of things to see what was the data out there. And if you look at the other countries that have really nice, Taiwan, Hong Kong, that have that really nice flattening of the line, they were all wearing masks. So here we have Petri dishes. Now you take somebody, they'll cough in this plate, and then you cook it in the incubator at body temperature and you look at it. So here they go, respiratory droplets after coughing, 15 seconds. So you wait 15 seconds, you wave that dish, okay? Put the lid on and you put it in an incubator and look at the amount of bacteria. Now we're not even talking virus here, we're just talking bacteria in the droplets when you've coughed at 2 feet, 4 feet, and 6 feet. So this is where the 6 feet came from, because with all bacteria, not mentioning viruses because this is a bacterial plate, looks like 6 feet, for a cough. So they did sneezes, singing, talking, and 2 coughs with no mask. So this was wearing a mask, no mask, look at the bacteria grow. Again, here you had a person with no mask. This is the droplets just waving that plate and catching it, putting it in an incubator, what one would get. So here you are, masked, there's really nothing growing. So that's pretty much stopping the spread of your droplets.
Well, Dr. Ortel, so that was very interesting, and thank you so much for sharing all you've shared so far. And I like to kind of interject. I want to introduce myself. I'm Dr. Okesanya. I'm actually the moderator of this conversation, and I also want to introduce Dr. Joyce Grossman, who is also on this call. Will also be kind of sharing her own thoughts and experiences about what we're kind of seeing within the COVID-19 phenomenon. I mean, already right now, I see here that someone has actually made an interesting question here. I know that Dr. Ortel kind of mentioned here that saying the decreases within New York, New Jersey, we're thinking there's a possibility of an element of herd immunity. So I have a question from Dave here saying, well, who says that these declines are herd immunity? I mean, and rightly so, because if we are saying that we have herd immunity, would it not be also be said that we don't really have to social distance, right? Because then if there's herd immunity, then there's no need to distance, right? Because we have the antibodies that are protected. I mean, Dr. Grossman, what is your thoughts about that?
All right, well, my thoughts are, I'm not totally convinced we have herd immunity, because in New Jersey, Hoboken has had outbreaks. Westchester, I think it's Chappaqua, has had an outbreak because there were a bunch of high school kids that were celebrating their graduation, and that was stifled by close contact tracing and isolation, so that if there were herd immunity, I don't think we would get these hot spots. I think that, yes, we have more people in New York and New Jersey who are immune to this virus than perhaps the data is showing, but I still don't think we've reached herd immunity. And I think that we still need to do, all the steps we've been doing, keep 6 feet distance. And I think wearing masks is very important. I think really there are very good studies that have shown that wearing masks does decrease your infection rate.
I think as the clinicians, are you hearing from people that they don't want to wear a mask? Because what I tell them is you can wear the regular mask, you can wear a shield, and there's something called a duckbill. So it's got more length when you put it on your face. It gives you more airspace in front of your nose and your mouth, so you don't feel claustrophobic. And then some people said, well, you keep breathing your same bacteria in. Well, you could simply change out your mask. So if you have a cloth one, you can put on a new cloth one. And for those of you who have paper masks, they can be sterilized in the oven. So there's a lot of things you can do. I think it's 350 degrees for 20 minutes. They put them in a paper bag.
Right, I think if I could weigh in a little bit, maybe what we see as clinicians, what I guess the objections to the mask. I think a lot of people feel it's stifling, and then I think also what unfortunately I think the initial rhetoric was that the mask does not protect you, but you wear the mask to protect others, and I think in some ways that seemed to, then everyone is kind of feeling like they're the other. I mean,
yeah, let someone else wear that mask, not me.
Right. It's like, well, I don't have it. And so and I think it's unfortunate that there were a lot of mixed signals in the beginning. I think that's really been a situation that's kind of been happening here. And I think also, I think that there is this, the initial rhetoric that came out, it was like, oh, well, only people who are certain risk factors are likely to get this virus. And so I think it made a lot of people relax. Like, well, I don't have any risk factors, I'm not going to get it. But unfortunately, that's not really what we've always seen. And I think sometimes, some people kind of look at things and they say, hey, I'm healthy, I'll roll the dice. And I think
So, Adesuwa, I have a Dr. Salahuddin Ahlasa, one of the very deep, insightful knowledge base here. He has raised his hand, and I have given him ability to speak here. Dr. Ahlasa, go ahead. Dr. Ortel is familiar with Dr. Ahlasa. And,
Hi, Dr. Ahlasa.
Hi, Dr. Ortel. How are you? You're everywhere.
Very good.
You've become famous now. Yes, and I admire Dr. Ortel, all her information. It's very cutting edge and updated. So yes, having Dr. Ortel here is it's an honor for everybody here. But my thing is that I used to believe that COVID-19 can only affect vulnerable people, which they find out people obesity and cardiovascular problems and diabetics. They are the more high risk, even more than the respiratory problems, patients with respiratory problems. Why? Because the COVID-19 is more cardiovascular, affect the endothelial of the blood vessels. But now there's a lot of reports where also healthy people can be infected and they can also experience the complication of COVID-19 and can lead to death. And that's why we hear that doctors are getting the infection and they die from COVID-19. So here it's very important to know that the risk of COVID-19 complication and death is also related to the dose that we are getting infected to. I mean, how much viral load, how much of virus particles we inhale. It's very important and critical to determine how severe is the COVID-19. And that explains why healthy doctors are getting sick, complicated, and dying from COVID-19. And that's why we have high risk of those of the healthcare providers of dying and getting the complication of COVID-19. And then we need to protect the healthcare providers as much as we can. So they are the high risk people of receiving or getting infected with COVID-19. So I used to believe that only compromised patients and patients with immune compromised and sick people only get the complication. But now I believe also healthy individuals can get infected and die from COVID-19. It depends on how much of viral infection particles that they get. And right. So it is very important to do the masking. Why? Because the masking will decrease the number of the viral particles in the air, the aerosols, especially in the hospitals where the doctors are getting infected. And so wearing the mask is very important to decrease the amount of the virus particles, especially in closed rooms. So that's what I'm trying to add here.
Thank you very much. Yes, and we're going to go into some more of those side issues further on in the lecture and in the lecture series. So Dr. Halasa was talking about viral load, but there's also individual variation and susceptibility. So, you know, what do we really need to get herd immunity? And we talked about if you have 60 to 70% vaccinated, and that's really where that number comes from, the vaccinated people. But if we were all the same, we all looked the same, we all weighed the same, we all ate the same, so we were, we had the same vitamin D level, all those kinds of things, then we're more likely to take longer to hit herd immunity. In a natural epidemic, though, so this was a very interesting topic, is that the coefficient of variation, that is how different is the population, may change how many people you need to get infected to really get herd immunity. And so that's why it's interesting to see that most of the secondary transmissions are caused by only 10% of the people. And we call them super spreaders. So they're the people who are the social butterflies who go out and in a day they were meeting over 120 people. That was, there was a newspaper article about someone in New York City on his contact tracing list was a nightmare. He had over 120 people. And then we hear a story from France where there was a young school-age child who had about the same number. He had 127 contacts, and not a single one of his contacts got infected, where the New York City person had a cough and they were positive for COVID, and the cough just increased the spread unbelievably. So the data is showing us that close contact, so you know, among your family and friends, if somebody has COVID, you're likely to spread it. The numbers tend to range between 7 and 10% for the most part. But the environmental factors, things that help to increase your viral load, okay, air circulation. So we know if you go to some place that's air conditioned, and there's a lot of people talking without a mask on, so that would be a restaurant or a gym or something like that, where you're going to have more viral droplets you have more viral particles and more droplets in the air. And how many people are, if they're staying in one place, are they moving around? And so what that meant is in grocery stores, they had done all kinds of studies, and they showed that if you made everybody stay in a line and snake through the store, it was much better than if people were merging and going by each other. There was a lot less viral spread. And then of course we all know people who are heavy breathers, who are wet breathers. If somebody gets close to you and they talk to you and you get their spray from their speech. And then we'll get into some of these things a little bit more, like the individual ability to shed virus into droplets. So if they're a heavy shedder, did they get a big load, and they have a big load in their nasopharynx and their mouth, let alone their lungs, and when they're speaking or singing or talking loud and they're pushing those droplets out, does that make a difference? The amplitude of speech, so we really, it's hard to test this on any one particular person. So we all know people who have wetter speech, who could be super spreaders. So that's why another reason why everyone should wear a mask. Those people are less likely to spread. So in the end, the super spreaders, those are people who make a lot of droplets, and they can have a high concentration of viral particles in their droplets. For those of you who want to, there'll be a link in here so you can go and see and watch the virus or how the droplets spread over the course of time. We didn't want to take time with that tonight, but it's there so you can look at it later. Ooh, that was nice. It was working. So we talked about herd immunity. We said that yes, with a vaccine, they say we need 70%, but then other modelers are saying, maybe in an area where you're not seeing any new cases, maybe there is herd immunity, and that's because of all the individual variations. So that means we have there's a large group of people who will have about 5 social connections versus, the very few people that will have like 50 social connections, like the person in New York City that was over, could have contacted over 120 people in one day. How many people are like that? Not many, but those super spreaders are out there very early. They get sick, they spread the infection, and boom, that's where you see the pattern of, it's case, 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 cluster, cluster, boom, from the super spreader. So they've gone out there and very early on, and they get all the people that are around. So once the super spreaders get sick, they die, they get immune. This particular paper was talking about the epidemic may be largely over, because the rest of us, we don't have that many social connections. If we're being safe, we're doing social distancing. If we're wearing a mask, then perhaps we can get out in society and get on with the rest of our life. So I wanted to look, okay, how's everybody doing? So we have Spain and Italy. Spain was beige, so look, went up high, came down again, and green, Spain and Italy went up high, came down. Peru is doing that little jog thing. We've seen that. And this is the UK. They were going to let herd immunity go. Then they tried to do social distancing. They were looking pretty good. The US is starting to go back up. And Arizona is, look at that.
So we promoted Arizona to be a country.
A state. Well, it was on here, and it was interesting. I think Dr. Ding, he's an epidemiologist, put it in just so you could see in the United States, how Arizona is a very populous state, and my gosh, look at it. It's like the worst, almost the worst we've seen anywhere.
You know, this might be an interesting time to kind of discuss this. You know, actually, just the New York Times just released an article kind of like talking about Sweden, and now we all know that Sweden decided, you know, bravely, unorthodoxly, to kind of just say, hey, we're just going to continue everything and not close things at all. And I think the New York Times was kind of making the article was kind of making a point saying that, well, them doing that not only kind of exposed them to a very high death rate, even higher than us, percentage-wise, of course, but also didn't really gain anything economically. And I think that's something, you know, people should probably take to heart. I think a lot of people feel, you know, when they feel the pressure to open up and kind of go out in the world, and the argument being, hey, we need to kind of salvage our economy. I think that's something we should also kind of look at too, that there are other countries who have done this and economies haven't gotten better. And that's a little bit of an aside, a little bit outside of the medical, but I think that is a big pressure for a lot of spaces. The argument that, well, we can't let everything medical rule. We have to kind of think of the economics. That's always,
and that would be such a wise thing if people would social distance and wear a mask, but that's not happening.
And that's not happening. And so I think so the narrative probably, you know, would have been, yes, let's try to really enforce people to wear a mask, and then yes, try to engage and try to figure out how to engage in economic activities. Dr. Grossman, you want to kind of...
I mean, I was going to say that in Sweden, its neighbor Norway went about it the very opposite, with masking and really trying to keep, you know, 6 feet distances. And Norway does not have a runaway outbreak, whereas Sweden is really, you know, it just keeps going up. And what Sweden shows pictures of are all the young people going out. Well, yeah, they're young and they're having fun, but we don't know how sick they are. And I've heard, I don't know any personally, that the older people are just stuck in their houses. They're scared to go outside because it's dangerous out there. So it doesn't appear to really be a workable way to handle it. And another example, if you want to go to a country where you'd say, oh, it's warm and there's a lot of sun, even though it's wintertime now, is Brazil. Brazil has a runaway outbreak, and Brazil has been handling it exactly the same. You don't need masks, you don't need social isolation. And Brazil is really having a big problem. So that obviously doesn't work, because the whole idea behind this was, well, give it a little time and we'll have herd immunity and it'll go away.
Right.
And yet we saw with Japan, Taiwan, Hong Kong, South Korea. I don't mention China because we're really not sure about their numbers. They seem to have hit a home run.
Right.
So just to finish up on this topic, the theory that we would need less to have herd immunity would mean that we all, we're all different. We're all so different. And because we're different, we're obese, unhealthy, diabetic, vitamin D deficient, low immune system. So a lot of those people got knocked out in the beginning. And now that they've been identified, you can self-identify yourself as being, in one of these, you continue to do your social distancing, you wear your mask, and that maybe we only do need 20 to 25% in certain places. And we talk about New York City, and I'm grateful for the people who live there to tell me, some of the boroughs and that aren't doing such a good job. But overall, like up here, you can see that it was pretty much looking like the number of cases were tapering off in some of these places. So that may be, the 8-week process, that this is what happens. Go up, come down, and you don't go to zero. We haven't been that good, but at least if we could, keep that up and let everybody go back to work and keep that up, That'd be great.
You know, I agree with you, but with New York City, I mean, I live in Brooklyn, and so I'm still waiting to see what happens because Brooklyn, I mean, New York City really was very strict. We tried, even during the demonstrations. If you notice, the people who are demonstrating try to keep away from each other and were wearing masks. I think New York City put in a big effort. The only thing is now, it's warm. Everybody wants to hang out. And it's hot.
Yeah,
it's hard to wear a mask when it's hot. So let's see what happens now. I mean, that's my fear, is let's see if we don't get another uptick in our cases.
Because, you know, compared to the European Union, which is the blue, that they're looking good for overall.
Right.
It's nice and stable. They can get back to normal, but they don't want us coming to their country. Look at this uptick, and that's mostly the 19 states.
Right.
Well, New York doesn't want, New Jersey and Connecticut doesn't want anybody from these other states coming in also. And we've tried to put in a rule, I don't know how well it could be enforced, that people coming in from these other states isolate themselves for 2 weeks.
Yeah, New York, there was a good New York Times picture that I've got in here, probably further on. But there was a mass exodus from New York City, and the New York Times used change of postal address. And you could see where everybody went. They went to Florida, Chicago, and the East Coast. That was the 3 major places that they went. That was very interesting.
Oh,
so I wanted to get into another topic, and that is some of the genetics of the mutation. So from the very beginning, I started watching how the mutation rate was going. And you can go to nextstrain.org, I think it's org, and follow how many. And so, you know, it was like 100 different strains, and then there's, or mutations. And now there's, you know, over 10,000 mutations. So what this slide does is show you that no matter what continent you're looking at, when they're doing the genomic studies, this is the difference in the number of mutations and what it looks like. So no matter where it is, it's mutating at about the same rate. And remember, a lot of these mutations are going to be the same. Okay? So in the beginning, they had a couple come out and people said, well, it's too early to tell. You can't really say anything. But really, there was the Wuhan strain, and as soon as it came out of China, there is some a mutation that took place, and that's called the European strain. And they changed a D to a G at number 614 at the spike protein. And so this is very interesting because this came out, this was published in April. It came out of China, and they were saying in China, so like, where's their Wuhan strain? So here, very early in China, we're getting the European strain. Isn't that interesting? Mm. And then this was the Washington clade that was more like, one would say, the Wuhan strain. And we may end up seeing this chart again, and I call her Zulu 11. There was one person that shed virus for 45 days, and we saw this very early in China. So that's interesting. So we're going to dig a little deeper, and let me do a couple of slides, and you know, if you have questions, go ahead and ask. So this one mutation was increasing in global frequency. So everybody says, so who cares if there's a mutation, if there's a lot? It doesn't mean it makes it more infective. So, okay, fine. So we're going to follow this one. So, so I say the D to G, they call it a G clade because it went from D. Now, when you look, most of all the European strains, American, they're all this G clade. And this has showed up again in Beijing. So after Wuhan, now you heard in China, they had a few more cases bump up. Guacamole, you got to try to get them down. Well, in Beijing, they were seeing a lot of this G, okay? So, but there were other mutations besides just this one. And I'm going to talk a little bit about that one, but the G-clade one was very interesting and everybody wanted to know, but does it mean anything? So they started looking, and the orange here is the Wuhan strain, so that had the D. And then the G was the mutation, that's the blue. And look how in the world, the blue is taking over, okay? In Europe, you can see they almost started like the same time. There's a blend of orange and blue. Then pretty much the number of cases in Europe is all blue. I found this very interesting that in England, there was 2 blue spikes. And there's a mutation that came out of Sweden, England, and Wales. In addition to this mutation, so I was wondering if this was like a G-clade, and then this is when that Sweden, England, Wales mutation came out. And we don't know if it made it worse, but it certainly looked like there was another wave here. Fascinating stuff. And in Asia, Australia, the same thing. It all starts, Japan starts off as the Wuhan strain, and then we get the European taking over. And the rest of this is buried for me, but basically that particular G-clade is taken over. Now, does that make a difference? And also, the European strain came over from, England, Italy, Spain. When we let all those Europeans in, we didn't close the border to them. We only closed them to China. So this is the slide from the New York Times where look where everybody went from New York City. And they changed their addresses. So this is the number of addresses that changed from a New York City metropolitan area to some Fort Lauderdale, Miami, West Palm Beach. The arrows are about how many people went where. So when we talked about the G-clade, the Chinese just came out with a paper and they said they're not defenseless. When you read the paper, it was about 7% of the people looked like they didn't have antibodies to this particular spike protein and could be getting it again. So that was interesting. And they did this by growing it in a virus. So to see how effective was it. So that was one of the first ones. And so they went back and they were looking at influenza-like illnesses. And look at the spike before we knew there was COVID of influenza-like illnesses. Here's Louisiana, Washington State at that double hump. Could that be Wuhan? Could this be European? And Iowa would be European.
Well, this brings an interesting point here. I mean, so I think there's been a lot of debate, I guess, with the COVID infection, giving you antibodies that are actually protective from future infections. And I think, and what you're saying here, I mean, I guess there's so many things that kind of come to play with that, because there's a question of, okay, do they make antibodies? Because I've heard a couple of things like, oh, some people make antibodies and they disappear. Now there's this instance of, well, now there's a possible another strain, and now you're not going to really be protective if I had antibodies to that. And then there's some people altogether that are saying that they just really don't think that the antibodies really make a difference. I mean, Dr. Grossman, do you have something to kind of?
Well, okay. Basically, I mean, it's a hard, the fact that it's a coronavirus, which mutates fairly quickly. I mean, whether or not the antibodies are protective is a big question. Remember, you get colds every year. And if you have antibodies, they don't seem to do very much for it. But it also seems that the mutations are giving this virus a different picture. I mean, and anybody could comment on this. I read the data from Wuhan, and in Wuhan, it seemed really a lot like a respiratory illness. I didn't read anything about microemboli, renal failure, the myriad of brain problems. Whereas once it seemed to hit, the United States, the East Coast, the West Coast to me seems more like Wuhan, which made sense with the fact that people from Asia usually go to the West Coast. But it seemed on the East Coast, we had a more virulent strain. I mean, this virus was doing things that were really very, very non-expected. So it looked like there was a mutation in the virus. But I have to say, and the media kept saying there wasn't a big mutation. But this virus was doing different things. And even what we're seeing now, I mean, there's been a report that there's been a mutation, and the virus is not more virulent, but it's more contagious.
Yes, and Scripps has had a really nice paper they put out that showed that the G-clade, it stabilized something they call a salt bridge, that has to do with the positive and negative charges. And because of this one little change, it made the spike protein more bendable. So if the spike is attached to a cell and something hit it, before it would have just broke off. But now, because it's more bendable, it just got bent, and when the thing went by, boom, it didn't fall off the cell. So that's the difference. Well, so we're on slide 32, and we've pretty much done our 45 minutes.
Mm-hmm.
Do you want to open it for questions?
Yes, I think we can open up for questions. Please, if you have any questions, feel free to raise your hand, or you could also type a question within the chat box, and we could be able to.
I don't see the chat box, so if you could tell me what the questions is.
No, not a problem. I'll relay the question.
I'm going to open up anybody to talk, so this way, everybody can talk. I'm going to try. So there are two hands raised. I believe, Yelini, do you want to ask your question first? Because I really see that one, Yelini right now.
Yes, so it seems we don't really know how long immunity lasts, and therefore, how could we count on herd immunity?
That's a good question. And see, we don't know the answer to that.
Okay.
Dr. Grossman, do you want to kind of?
Yeah, actually, what I wanted to say is what Yelini is pointing out is the problem with, passive immunization using either antibodies or monoclonal antibodies, because if we're going to get mutations and in this virus, it may be in a very short period, these treatments are ineffective, and it really, really makes the prospect of getting a vaccine, which is now the holy grail that everybody's running after, much more elusive. Because I could vaccinate you against this strain and you say, wow, I'm safe. I don't need a mask. I could do what I want. And the virus goes and mutates and you get deathly ill. And you say, how could that happen? I was protected. You see, and these are the lurking questions in all our, efforts to really, really conquer this virus.
Dr. Halassa.
Yeah. Let me just add something here, very critical, and then I need you to confirm or you agree with me or not. So it's a statement, then I need you to agree with me or not. I believe in Sweden approach in opening up the businesses, but because Sweden scientists believes that healthy individuals, they will not get sick or get complicated and die, only the vulnerable people. And so that's the problem with Sweden, but it's proven that the healthcare providers, healthy ones, are getting infected sick, and die. So the factor of the viral load was missing in Sweden. And it's very important to recognize that factor. And once we recognize it, then we start doing the masking. And where are we doing the masking? When we go to the closed space. That's very important. When you go to the shop, you have to wear the mask. Outside, you don't need to wear it. Why are we doing that? To decrease the viral particles load of that shop or that closed compartments, or house, or whatever it is, shopping center, whatever it is, or the clinics or the hospitals. It's very important that the viral load of the particles of the room needs to be low. Otherwise, if it's high, then even healthy individual can get infected, complicated, and die. So the idea of allowing healthy people to go out to get infected, it's good, but not over-infected. So what's that mean? Open up the business, allow healthy people to go out, but wear the mask, social distance, so they don't get over-infected. They get enough infection to get the immunity, to get the herd immunity. Now, again, I don't believe in vaccine will solve the problem. Why? Because, as you said, that the mutation can happen. So once they develop the vaccine at the end of this year, virus change like a flu, so that vaccine will not work anymore. So how we solve this problem? What's the answer? I think immune boosting, it's very important, vitamin D and all that things that we're doing as integrative doctors for everybody, healthy and vulnerable people. But also recently, there's at University of Washington, they are developing masks contain methylene blue, and they find out it's a good approach for killing the virus. So I will share that articles for you. Myself and my group, we are promoting oral photodynamic therapy with methylene blue, which is mouthwash of methylene blue, and you put the light at night, especially for healthcare providers. It's very important. After you wash your teeth, gargle that methylene blue, put the light. That helps to decrease the viral load. Because as I said, the factor of viral load was not being recognized, and it's not being recognized yet by the medical community, nor by most of the doctors. Now we need to recognize that factor. And knowing that, then we can emphasize the importance of wearing the mask and social distancing, not to avoid infection, but to avoid over-infection, which is getting too much of the virus where your immune system will be compromised and you end up sick and die. So this very, very important point that will, if this message is being delivered to the medical community, then it will be, I think the healthy individual, the young people will understand that, you can get infected and die if you've been over-infected. So the idea of you are being protected and it's only causing death for vulnerable people above 65 and people with disease, with underlying disease. That's true, but also healthy individual exposed to too much of virus can also get infected and die. So this message is being delivered to the medical community and to the public. Then the young people will be taking wearing the mask and social distance more seriously. Thank you.
Yeah, I agree. I have just one other comment. In the United States, I mean, you could comment on this, we have a problem with obesity. So, in other words, people that think they have no risk factors may really be obese. And we know, probably because of that, I think the ACE2 receptor, they seem to be more vulnerable to this virus. And we have a huge population that's obese.
Right.
And I don't know if losing weight will help or getting fit, but I mean, I think that adds to what you're saying. Yeah, there's a viral load, but I mean, we have another problem that's brewing in our healthy population.
So Dr. Halasa, am I pronouncing this right, Dr. Halasa?
Yes, you're right.
Hi, Dr. Halasa. So, you know, you bring up an interesting thing here, because that's an interesting theory. Like, okay, well, look, you know, and I've always said to people, and I feel most people really believe this, of course, eventually everybody's going to get coronavirus. I mean, the only point of all of us doing these things is to slow it down so we don't overwhelm the health systems. Now, so the question is, but now we have all these people coming around and they're doing COVID parties. Now, I think, so would you want to comment on that? Like, when people feel like, okay, they're taking this to the extreme, they're like, well, yeah, we should all kind of really push for herd immunity, and now they're doing COVID parties. I know what.
They did that for measles. They used to have
Yeah.
they'd have a party for measles, and everyone would exchange a t-shirt. So whatever t-shirt you were wearing, you gave it to the child next to you and you put it on, and you got measles. But measles gave you a very mild disease. You know, you weren't going to die from it. Right. We have so many different variables and comorbidities that it's very, you know, and these young people can look perfectly fit, but there's data we'll probably get into in the future where they could have, you know, some SNP that makes them more susceptible. There's Italy, there were 6 or 7 SNPs that the Italians were carrying that caused them to have really severe disease. And so there's different ethnic groups have different risk factors in them.
Right, absolutely.
No, but here's the thing. Even healthy individual, completely with no SNPs, healthy completely, if they exposed to too much of COVID-19 virus, they can
get a big load.
Yeah, they can't overcome that. No, I agree.
Complicated and die. Okay, so that point was not. This message was not yet in the medical community yet, in the public yet, because this very important message needs to be delivered. Why? Then here, the youngest people, they have a high risk of dying it complicated if they've been exposed to a high dose of this virus. Now, low dose of virus is good. I'm with exposing healthy individuals with low dose of virus. So going out, get mingled, but not over infected, not over mingling. In other words, you have to wearing the mask is very important. Social distancing is very important, so you can get enough infection for you to develop the antibodies and contribute to herd immunity. But if you get over-infected, like if you are all in one room, all those young people, let's say 30 young people in a closed room, partying, mingling, and mixing, and we have one of them are sick and shedding this virus, and the viral load in the room is very high, those people, they can get infected and complicated and die. And that's the reason why the healthcare providers, healthy young healthcare providers, I know them personally, okay? In UK, some of them are my colleagues. They got infected and they got sick, almost died. Some of them died, and they don't have no underlying diseases. Why? Because they got over-infected. They got too much of viral load. They're seeing a lot of patients, and they are shedding those particles. They receive this particle from this patient, adding to another patient, third patients, and they got sick. Some of them died. Some of them, they survived, but they got sick into pneumonia, and they get into all this intubation, all that stuff. So this is very important message, because if we don't deliver this message, then we are shooting in the dark, and we are risking our people into getting infected and dying, especially those health individuals who think that they will not die or get complicated from the virus. So this message needs to be clear, and that's why wearing the mask is very important. Social distancing, I think it's very important, but also contribution of herd immunity, getting infected, not over-infected, is also important, because if we don't get infected and we flatten the curve too much, then there's a problem. Then we'll be expanding the whole period of COVID-19, and that's a problem as well. Then we have a lot of problem with the economy and shutting down and closing and all that stuff. What needs to be done in the moderate way, not like Sweden and not like, let's say, for example, New Zealand. something in between like Germany. Germany is a good thing. It's a good example. I'm right now currently in Germany, and I like the way that they are handling COVID-19.
Interesting. Nice.
It's interesting, yeah. So the Germans, they have a low baseline level of the virus now.
Yeah, the Germans, they do social distancing. They're wearing the mask. They are very disciplined in doing that. So when they go to the shop, all of them, they're wearing the mask. When they go out, they take out the mask. So I think they are developing the herd immunity slowly, getting infected, but not over-infected. I think they are isolating the vulnerable people, the seniors and all that stuff that needs to be isolated. But still, you know, if you say you're going to isolate the vulnerable people and wait for the vaccine, I don't think it's an answer. The reason why, because this virus can change, and once the vaccine is out, we have a new virus. So this
I agree. I mean, to me, it's very worrisome that there's so much of an effort being made, you know, for a vaccine to a virus that mutates so quickly.
Yeah.
I know it's hit 8 o'clock. I'm going to stretch this out to 8:05 since there are so many questions and discussion. Dr. Ortel, would you mind going all the way to the last slide so that we have the information about Q&A and the next session? And then I believe Dr. Okesanya, go ahead. I'm sorry to interrupt.
Oh, yeah, no problem. I think we had somebody else who wanted to make a comment or had a question. Is it a Dr. Yalani?
Oh, yes. So I had two questions about sort of the social communication aspects of this. One is there were, you know, our minority communities and others are heavily affected. But in Asian countries, the measures that were actually taken were much stricter, and there were some small immigrant communities, for example, in Italy, Chinese immigrant communities in Italy and in BC, Canada, where they were very strict among themselves and they headed it off. And I wonder if that kind of, you know, going one better approach might be possible here.
Each person taking personal responsibility.
But also a community organization, because you might need things like masks and, you know, if you have a job that involves deliveries, but the thing is people could, yeah, take more responsibility and act more according to the science than they're being advised. And then the other thing is, some of this seems to me, because obviously for medical privacy reasons, we don't see people and you know what it's like being in ICU, not being able to breathe and all those things. But maybe if some people were willing to have themselves filmed in those circumstances, it might help convince people that this isn't a hoax and that they need to take it seriously and they're not just necessarily going to have a cold and recover and stuff.
Well, I mean, Dr. Ortel, I mean, what are your thoughts with that? I think, I mean, I think personally, I definitely believe, I think a lot of our, well, how should I describe, our missteps somewhat, or our difficulties with this virus has kind of been our messaging, straight even from the CDC, from the government. I think there's definitely been a lot of mixed messaging, for sure. Yeah. And I think there hasn't been a lot of community ownership. Some communities have, but I think definitely that should be really a goal, to really reach out to smaller community packs and kind of say, hey, you know, we should really try to encourage our communities, you know, on a more granular level. Hey, this is what we need to do, and this is why it's important.
Yeah.
Well, I think that the elderly and people with complications have been very good about isolating themselves, being cautious. I think the message has to go out to the young people who feel they're healthy and invincible. And when they go out on the beach, you know, in Miami, they say, hey, we're young, we're having fun. What do we care if those old people get sick? And I think it has to be reinforced, maybe by media, that young people get sick and could die.
Yes, that reminds me, there was a case of a young 20-year-old girl who needed a lung transplant. This was in the media, and they said at the time of her transplant, and they removed her old lungs, they had to like scoop them out.
Wow.
Yeah, I mean, and the young people who've been placed on ECMO to save their lives. I mean, you know, that is very invasive. These are the type of stories that have to go out. Not that this is an old person disease.
Right.
Yes, for whatever, for multiple reasons, the media has not been helpful.
No, not at all. Not at all.
In getting out the truth, right? The truth. So
well, I think and also too, you know, to be fair, the truth is, people say truth is the daughter of time. And quite honestly, I think with this virus, I mean, we kind of needed some more time. And I think it's hard because the virus is new. And so I understand the missteps for instance. Could we have done better? Yeah. Is it understandable, some of the missteps? Yes. Can we try to change the narrative now where we are? I think we can. I think, so it would be great if we could probably try to get a handle, with communities and kind of get that message out saying, hey, this is what's going on. This is really what's needed. Can we have really everyone comply and kind of get together and do that? Yeah.
Well, I know we had a very good session. It's 7 minutes past 8 o'clock. Because of the amount of discussion, I thought it's worth stretching it out a little bit longer. But this is just the first of 14 sessions. The first 1, 2, 3 sessions are going to be with the 3 people that you're seeing here, Dr. Ortel, Dr. Grossman, and Dr. Okesanya. And it will be continuation of this discussion. You actually be missed we are at slide 69. There was a lot between slide 26 and 69 that we skipped out that Dr. Ortel can bring back up. It also includes the origination of COVID and suspected created versus natural, and that area is very interesting. And this is all evidence-based that we have put together. So if you have the ability, please share about the series, and we want to have more people attend. And towards the middle and later part, we're going to have public health, tracing, immunity, PP, and also the finance, healthcare, what's going on the healthcare finance side of this whole thing, hospitals, bankruptcies, financially impacted because they're not able to operate. The last piece will be about vaccinations, what is available, who's working on what, and what's close to, and what has tried and failed, because we did have reports about certain companies who were working on vaccinations were forced by FDA to say, no, they cannot work on that because it's not working, it doesn't work. So that kind of thing. Thank you so much. Dr. Okesanya and Dr. Ortel, Dr. Grossman, do you guys have anything more to say?
I think it was an excellent first discussion. More like a round table. Very good.
Yeah, absolutely. Absolutely.
Yes, no, I thank everybody. It was a great discussion.
This is a recorded session. We'll be sharing this on YouTube somewhere.